Okay, in this video, we're going to be looking at Unit 3, number 11, where we have to find the domain. Okay, it says the graph of a y equals f of x is shown, which I'm not sure why they said A. The graph of y equals f of x is shown. The domain of f of x is what? So the domain refers to the inputs or the possible x values. So we can see that on this graph f of x, we have ordered pairs all along here, and those x values fall in between -5 and 4, including the -5 and the 4. So it's from -5 to 4, where you have brackets on the -5 and the 4. So bracket -5, comma 4, bracket. Now we're supposed to find the domain of g of x, which is the square root of f of x. So when we're looking at what are the possible x values, it's often helpful to think which ones are impossible. So Jessica, it's impossible to take the square root of what type of numbers if you're in the real number system?
I honestly don't know.
It would be negative numbers.
Okay.
The square root, no even root of negative numbers in the real number system. That kicks it into the imaginary in the complex numbers, the complex number system. So we are going to need to look at where is f of x negative. So up here, here's our graph of f of x, and we can see that f of x is negative. Those y values are negative below the x-axis. So from -2 to 2, we have negative values. So our domain, the possible x values will be from -5 to -2, and from 2 to 4. Now we need to think about the actual x-intercepts at -2 and 2. So we have a y value of 0 here and a y value of 0 here. We can take the square root of 0 because 0 times 0 is 0. Therefore, we will include the -2 and the 2 in the domain. So our domain is going to come from -5 to 2, including to -2, including the -2, and from 2 to 4. Then you put a union symbol in between those two intervals. Okay, do you have any questions about that?
Well, I think that leans into what my other thing that I'm struggling with is and I think it's interval notation, the union symbol, the brackets, all of that.
Okay, so if you are including the endpoints, you put brackets. If it would come up from -5 to -2, but not include the -2, then you would put a parenthesis. Like if it gets infinitely close to it, but doesn't include it. Now, the union means anything in this region or anything in this region. So you're taking all of both. If it was intersection, the upside down U, that only takes the overlap, which in this case, there is no overlap in between these two sets, and you would have the empty set. So let me just give you an example here. Let's say you were trying to make a graph of -4 to infinity on the x-axis and 2 to negative infinity on the x-axis. If you are going to use the union, let me just write down an interval notation. So if we start at -4 and we go to infinity, that's the same as all the x values greater than 4.
Where did you get the -4?
I made it up. I just said, let's say we want to start here and go all the way out to infinity. But let's
Okay.
say we want to union that with all the x's less than 2. So all the x's less than 2 would be from negative infinity all the way to 2. And I don't have an equal to on it. If you're
Is
doing
that
the union, it's going forever to the right and forever to the left. It includes the entire number line. So you could just say all real numbers are covered in that union. But if instead we put the intersection of those two sets, that would only be the overlap. And so those two graphs are overlapping in this region from -4 to 2. So the intersection of those two sets would be from -4 to 2. And we put a parenthesis on it because there's no equal to in either of these. Now you had a question?
so the brackets are when you write out like x is less than and equal to 2. That's when you do a bracket.
Right. So that's why you had brackets on this answer from -5 to 4, because this point right here, it's the ordered pair -5, 2. It includes that x value of -5. And over here, we have the ordered pair over 4, up 4. It includes the 4. So in the interval, you put bracket -5, 4 bracket. It's saying all the numbers from -5 to 4, including the -5 and including the 4. Now it can be confusing because this interval that I just showed you from -4 to 2 looks like an ordered pair. It looks like -4, 2. And the only way you can tell if it's talking about an ordered pair or if it's talking about an interval is from the problem. So I was talking about intervals, so you knew this is from -4 to 2. Over here, I said the ordered pair -5, 2, and I was talking about that point. So that's how you knew it was an ordered pair.
Can you
Don't
show
ask
me
me why mathematicians use the same notation for both.
can
Somebody
we
came up with it.
can we do some more examples for the interval notation and then I go over another example of this because I'm still not sure I fully get it.
Okay, what I will do is to show you another example, I'm going to go to the teacher examples, sample problems. Teacher preview. So we'll go to number 11 again. Okay. We're supposed to, first of all, find the domain of f of x. So what are all the possible x values here? From what to what?
Are we finding that just by saying where the line hits on it, or
Yeah, see, this graph is made up of millions of ordered pairs. The very first one is -5, 4. The x value of that ordered pair is -5.
so then the next one would be -4, 2?
Well, you also have the halves in here and the fourths. So you could look at -4.5 up 3. But yes, -4.2 is on there. So you have all these x values. And then what's the last x value?
5, 4.
The point is 5, 4, but what's the x value of that point?
Just 5.
5. So it's going from -5 to 5. All those x values are covered, and it does include the endpoints. So you would put bracket -5, comma 5 bracket.
Now, if the graph had a open circle, is that where we put something different, right?
Yeah, if there were open circles here instead of filled in dots, you would use parentheses
Okay.
here.
Because this is like a greater than or equal to.
Correct.
Okay.
Right. This is the x's here are greater than or equal to -5 and less than or equal to 5. So that the interval notation for that is given here. The inequality notation would look like this. X is greater than or equal to -5, and x is less than or equal to 5. Notice I use the word and because we're only taking the overlap between x is less than or equal to 5. We didn't, and x is greater than or equal to -5. We didn't go all the way out to negative infinity. We didn't go all the way out to positive infinity. It's just where x is in between -5 and 5. So that
And
is an example of an intersection.
because we're looking at everything in between the 2 points then.
Right. It's the intersection of x is less than or equal to 5 and x is greater than or equal to -5. Okay, now to find the domain of g of x is the square root of f of x. So we have to think, what are our possible x values here? And to figure out that, it's helpful to think about what's impossible. So it's impossible to take the square root of a negative. So we want to look at where is f of x negative? F of x standing for the y values. So our y values of all those ordered pairs are negative in this region. Like for example, this point here is -1, -4. That y value is -4. Or here we have -2, -2. The y value is negative. Anywhere below the x-axis, the y values are negative.
Is the
So,
y value also considered the range?
the range is the possible y values.
Okay.
The reason
'Cause
we're looking at that right now is that our g of x is the square root of the y values for f of x.
and
So,
the g of x is usually the range, right?
g
Or
of x
no?
is just, it's a fancy way of saying y. But the reason they call this one g of x and that one f of x is that it's two different functions. So they use different letters just to say, well, we've got a different function than the one we had before.
Okay,
And
so
the ordered pairs, they both stand for y values.
okay.
So we can see that our y values are negative in this region, but to give the domain, we want to talk about the x values of those ordered pairs. So the x values that work are the ones that accompany where the y values are positive. So my first x value in this region is -5. It goes to -3, or from 2 to 5. Those are the x values that accompany those positive y values.
Is this where we do like the two is less than or equal to x less than or equal to 5? Is that how we write that out?
You can say it's what you said is close. X is less than or equal to 5 and greater than or equal to 2. So that branch of the answer would look like this. From 2 to 5. So that's this branch. But we also have to union that with this branch here from -5 to -3.
So that's the writing it out in interval notation.
Mhm.
And that is because of the square root of f of x. So we
Yes,
have to get all the stuff that's above, that's not the negative.
right.
What is it called when we do what you wrote out, the -5 less than equal to x less than equal to 5? What's that called?
That is an intersection. Whereas this one here is a union, it refers to or,
Hmm.
this or that. Where and is referring to the overlap, where x is less than or equal to 5, but greater than or equal to -5.
Okay, I think that mostly makes sense.
Okay.
Um, I'm gonna see if I can find a couple of the problems from today I found
Okay.
that had to do with the domain.